Welcome to another episode of Empower Apps. I'm your host, Leo Dion. Today, I'm joined by Jill Scott. Jill, thank you so much for coming on today.
Hi, thanks for having me.
Before we get started talking about Humane development, I'll let you go ahead and introduce yourself.
Sure. My name is Jill Scott, iOS developer. Living in Charlottesville, Virginia at the moment.
So let's get started. What what exactly is humane development, and why, from your personal experience, why is it so important?
Sure. So humane development, it's a term that I first came across when I was reading a book called Code That Fits in Your Head by Mark Seaman. He talks about humane code. And the idea is that code is, I guess, at its root, a conversation. The idea of writing code, obviously it's to accomplish the specific feature or task that we're trying to do at that moment, but it's also to write something that other people are going to be interacting with. So when we write
Yes.
code, we're writing for future developers and for our future selves, not just for a machine. And so humane development is the idea of keeping that in mind while we're writing our code. So making sure that it's readable, making sure that it's communicating what we expect to the people that are reading it in the future. And I think I personally was really interested in this topic because I tend to be really distractible. I tend to go down the wrong paths. I tend to, fixate on logic that is completely unrelated to my future when I'm going back through old code. Um, and so the idea of humane development, of developing, keeping those kinds of limitations and those kinds of distractions in mind for future devs feels really important to me.
So let's say you're told to update some old code. What's excuse me, what's one of the first things you've noticed that developers do that are like bad habits when you've been given a job to do maintaining some of these old code?
Yeah. So I think when we're first developing a piece of code, a lot of us, definitely myself included, we tend to fixate on finding the cleverest solution to our problem, or the solution that gets it working. And that's important. It's of course important to accomplish your acceptance criteria, but it's also important, like I said, to communicate with what you're writing. So
Yeah.
a clever solution might not be the one that's most communicative. Um, it's tempting to stick with something that, honestly, something that looks complex and feels smart. That's why we're developers, right? We like to solve problems and we like to come up with clever solutions. But that doesn't mean that it is going to be the solution that is sustainable long term. There's always ways of clarifying code, and so I think one of the main mistakes that we make is sticking with kind of our first pass at code and not looking at it again through the lens of someone that's going to be reading it in the future. It's not.
Yeah. I mean, I just think we often don't realize that at the end of the day, this is all money, right? And um, I think we try too hard to write for code that's maybe fast or shows off some cool feature.
Yeah.
And like when a company's paying for stuff, paying for employees and paying for that time is going to be the biggest cost expense. And if your code is way too clever, that manager, that CEO is just going to look at that and be like, oh my gosh, this is a pain in the butt to maintain. We're spending tons of money. That creating code that's maintainable, easily understandable is going to be a lot more profitable to the company, and that means they're going to do well and you're going to do well than worrying about optimizing it for hardware that essentially is going to be replaced in like 2 to 3 years,
Yep,
right?
completely.
So I think that's like the big picture business reason, besides the fact that nobody wants to work for a company where the code is garbage and it's difficult to maintain, and then you're given tight deadlines, et cetera, right? And I think
Sure.
that's kind of that's the selling point, besides the morale issue of like having to work on a really horrible code base that's way too clever or just way too sloppy. And like you said, there's kind of a sweet spot in the middle. Well, it's not just a sweet spot, it's like breaking, I mean, to me it's like breaking things down into smaller pieces and properly documenting, I think, are two the big things that people should be doing when it comes to their code base.
Definitely, yeah.
um I mean, what are other things, I guess, what are some other code smells or red flags you've seen in code, especially I guess maybe in the iOS dev space especially?
Yeah. So I think a big one that you kind of alluded to is making sure that that things are broken down appropriately. Um, having a function that is 100 lines long is probably not going to be sustainable. Um, so definitely, yeah, a code smell would be having a super long function. It's
Mhm.
not always a bad thing necessarily to have a long one, but the chances are that the longer it becomes, the less readable it is.
Right.
And our brains can only hold so much information at one time, and so in looking at a function, for example, or just any chunk of code, the more meat there is to it, the more that we have to keep in our brains, and that makes decoding it really difficult. Breaking it up into functions lets us, name the function something descriptive, and it means that
Yep.
we probably don't have to go into that function and parse what it's doing, because it tells us what it's doing right there in the name. And so when it's called, that's breaking it up into a chunk that's really easily digestible.
Yeah, and I think there's there's a bad habit from the old days, as we get more into talking about actual solutions. There's a bad habit from the old days of like doing things, making things like var x or let x, and like not saying the name of the thing or having the function long because you're running on a whatever old univac or whatever. It's like yeah, you can't do that, everything has to be really like tight. But we don't have that nowadays. And also we have like autocomplete, we have the internet to look up API documentation, things like that. And I think you touched upon, I think an important piece that maybe we can get into a little bit more is how there's only so much room in our brain to hold this stuff in, and how our brain and how our memory works, how that ties into how difficult it can be to maintain code. You want to break that down a little bit and how memory works?
Yeah, for sure. So a lot of people are already familiar with two of the types of memory, which is short-term memory and long-term memory. Um, and those are, of course, super important in our day-to-day jobs, with short-term memory being kind of the list of things that we can hold on to in our head, just the pure information that we maybe like read an acceptance criteria or something like that. Long-term memory being, the stuff that we've learned about programming over the years. So we use that to inform how we work with short-term memory. And then working memory is a third type of memory that is, I would argue, the most important skill, or the most important thing that we use when we're doing our jobs. Working memory is what allows us to apply those long-term memory skills to what we're holding in our short-term memory. So working memory, like short-term memory, is also limited, and it's what allows us to employ the logic that's so important to what we do. So when we're going through and reading past code, we're using working memory in order to kind of manipulate the logic of that old code. So we hold on to what it's doing, and we apply it to what we're trying to accomplish in the code that we're writing at the moment. So working memory has a lot of characteristics that make it distinct from short or long-term memory, including, like I said, the fact that it's limited. You can only hold and do so much in your brain at one time, but also that it's really dependent upon attention. So you have to have a sustained attention upon the tasks that you're doing. And if anything distracts you from what you're doing at the time, you start to lose some of the information that you're holding in your head. So the way that translates into working with code is when you start to have to delve into old code and understand it in order to work on whatever you're working on at the time. If we have to pause and sort of parse that old code and decode it, we're going to lose some of the context that we have on the new feature that we're working on. We're going to lose our train of thought. We can no longer sustain attention on the things that we were trying to sustain attention on before. And, like it just kind of breaks our momentum in what we're doing. So yeah, working memory is super key, and supporting it and working with its limitations and acknowledging them is one of the main is kind of the main importance of humane development, is working for that.
Yeah, I agree. And I think like that's where you said, and we both said, breaking functions down. I would also say breaking types down. Breaking files shouldn't be too long. Like, break every type and extension into a separate file. Like, there's no. I think we just have a lot of these. We're in software development, so we're lazy to our benefit in the sense that we want to automate everything, right?
Yeah.
But then that laziness can sometimes mean we just put everything in one file and one function. And we should, don't do that. Put it in separate files. It doesn't cost a lot.
Yep.
We have IDEs that do autocomplete, and we can look up stuff. We've done an episode on all the little things you should know about Xcode to help you with that. And, whatever IDE you're using, heck, we have GitHub Copilot now. So we can even have the machine write the code for us. So, breaking things into small chunks. And then also, that gets to benefits with unit tests and things like that.
Yep.
What are some other strategies you've found to help you, that other developers have done or you've done to help make that code more maintainable? We've talked about breaking into small chunks. What else can you think of?
Yeah. So that descriptive naming that we already mentioned also. So there's a few points about descriptive naming, and so when I say naming, I'm talking about like function names, class names, things like that. Just anything that we're defining as a descriptor. So making names that are descriptive enough so that describe exactly.
Don't use X.
Yeah.
Don't use I
Sure.
in your for loop. Come on, people.
Yep, exactly. When you don't want to have to figure out what it's referring to. Again, that takes up, an important piece of working memory as soon as you have to pause and figure that out. So yeah, descriptive naming, making sure that it gives us enough information. Also naming that doesn't lead us astray. So sometimes, when we're doing a first pass at code, we might think that a variable is going to give us a piece of information that ultimately it doesn't end up really representing very well. So continually updating our names so that they give us the information that we're expecting and intending.
Do you have an example of where you've run into that? I'm curious.
Yeah. So let me think of something specific. Well, I can give you the example I gave in the talk that you attended. I was talking about validating this piece of code and displaying some red text when some criteria wasn't met. And
Oh yeah, I remember that. Yeah, that
the
was good.
the variable was called, like skill error or something like that. And so initially, when I was going over that code as a first pass, I was thinking that, somewhere along the line, it was going to throw an error. And since error is, a Swift type, we would expect to find an error in that code somewhere. As it turned out, I didn't use error at all. It was just, a validation that checked to make sure some conditions were met. So the type error was never used. And that means that, calling it whatever kind of error, skill error, was giving a wrong impression and leading us astray. So if I went back through that code, saw that, I would be looking for an error type and I would not find it anywhere. So
Yeah,
yeah, it's a pitfall. It again distracts us from whatever is at
right.
hand that we're trying to accomplish.
Um, Go ahead.
Oh, yeah, I was just gonna say, in terms of like other tools at our disposal, for making code more readable. There's one that I find a little controversial for some developers, which is just comments. I know that a lot of
Really?
times, yeah, I know a lot of devs that have read clean code, which is fantastic, and read a lot of books, and think that what those those books are saying is don't write comments. And so a mistake that people make is sometimes, you know, taking that a little bit too far. Comments
Right.
can be distracting. They can create noise if they're unnecessary, but they can also be incredibly helpful, especially from the lens of humane development. So, the person that's writing that code originally has a lot of context that the future person's not going to have, the future, developer that's reading that code later. So getting that sort of project context that the code can't self-document can be clarified with a well-placed comment. And I find those
Yeah.
incredibly helpful for, working memory, not having to go down this extraneous like track of thought.
Yeah, I mean, if you're doing like any public SDK for certain, you should be doing code documents, or you should be having comments and documenting your code and things like that. Also, think like at the very least, especially something that's it's pretty complex. Like use some the DocC. Not you don't have to build out a whole DocC documentation, but at least have like a header comment on your
Mm,
functions and types.
yeah,
Like
for
that
sure.
doesn't tell the story of what your function is doing, and what it's supposed to be doing.
Yep.
I want to say one more thing. I don't know if you've heard of this framework that's pretty popular right now. It's called SwiftUI,
Hmm.
but you can get some pretty, like, I guess they're computed properties or their functions. Bodies, I guess, are they're mostly computed properties. You can get some pretty massive SwiftUI views.
Oh,
That's a
absolutely.
great example of something that should be broken down into separate SwiftUI views.
Yep.
Anytime you're doing like a lot of like combined ninjutsu and you're doing a bunch of stuff with publishers, maybe that needs to be in a separate observable object that does that for you. I think that's a great example of where I've seen a lot of people fall into that trap.
Oh yeah. When you're going through some of those like nested views, if you haven't broken them up, yeah, it can be so easy to lose track of
Yeah.
where you're at in that like view hierarchy. Whereas if you're extracting those into their own views, you can name it something descriptive, and then you know exactly where you're at and exactly what that chunk of code is representing.
I think the other thing I was going to point out is there might be times where your code is messy, and that's okay. But at some point, like that's where a good pull request, you need to review your own pull requests, and you need to or at least have somebody tell you, like if you're reviewing somebody else's pull request, say you need to put comments in, say this needs to be broken down. I think that's another helpful guidance as far as like helping others make their code more accessible and make your own code more accessible.
Yeah, I think the whole code review process is an essential step in humane development because it
Yeah,
guarantees that somebody who doesn't have the context that you have when developing that feature is looking at that code. So they kind of represent the future developer in that context, because they're seeing exactly what points are unclear at first glance.
right.
So yeah, I totally
Right,
agree.
exactly. And like review your own code
Hmm.
maybe right away before you merge something in. Or one thing we've talked about before on the show is like maybe you look at your code a week or 2 weeks later where your mind has lost a lot of that short-term memory, and realize that maybe you need to work on your code comments and your refactoring, because that gives you that, like, you don't have the context anymore, and now you can be like, oh yeah, I should have described that a little bit, because now I have to look back and try to remember what I did here. That's what I've found as well. That's helpful.
Yeah, completely. And the more you do that too, you kind of start to be able to identify without having to wait, those 3 weeks. You start to recognize those sooner, those points where
Right.
code can be further refactored. It's a practice in empathy. I find that
Yes.
really interesting, taking yourself out of the shoes of current dev and putting yourself in the shoes of future dev.
So, what are some other things that you would describe as like accessible code and what that means to you?
Yeah, so accessible code, I think, we're all familiar with the idea of accessible code in the traditional definition, where we're thinking about the end user and the limitations that the user might have, and how to set them up for success, whatever their user experience is, and however it might differ from ours. So things like making sure we're using voiceover and supporting dynamic text, dynamic font sizes, and stuff. Those are all incredibly essential. But I think that there is another side of accessible code, and that is making sure your code is accessible to other developers. So making sure that your code base is accessible as well. And when we're talking about memory, working memory especially, it's really important to remember that not only is working memory like limited in all humans, like we all have, the extent to which we can manipulate information and remember it. There's a lot of people that struggle with it more than others. So like anything at any time can affect working memory. It's really susceptible to, I don't know, to like detriments, things that negatively affect it. So, for example, sleep and nutrition, even mood. You could just be grumpy, and it means that your working memory isn't going to be firing like it usually does. But then there's also any number of conditions and limitations that someone can experience that cause working memory to be lessened, and make working with code that much harder. So things like ADHD and autism spectrum disorder, any number of like physical impairments or learning conditions and disabilities. Um, Personally, this is another reason that humane development is such an important concept to me. Is I have ADHD and I have depression as well, and those two things together can create this kind of absolute mess of working memory. And I've found that focusing on programming for future me makes sure my code is that much cleaner. I know that there's people that are experiencing working memory limitations at any given time, and they need help. And that help comes in the form of writing good code. So I think accessible code to me is keeping in mind everyone's limitations, the fact that humans are imperfect, that brains are imperfect, and yeah, writing accessible code is making it as consumable as possible for all of us.
What when you've worked on like a team, because we all work on, and nobody's a like solo developer unless they're indie, right? But like when you've worked at an actual company, what have you found that they've done? What are some things, mistakes that they've made, and what are some things that they've done well to help you and your team actually write accessible code?
Yeah. So I think the primary mistake that teams make is just not accounting for how important working memory is to what we do on a day-to-day basis. Not not necessarily discounting it, but just not being aware of working memory and cognitive load. I don't think we talked about that yet, but if I can digress for a second. um,
Mm-hmm.
so there is kind of this intrinsic cognitive load to anything we do, and that just means the resources that are going to be taken up by working memory to do a task. And intrinsic cognitive load is, just kind of the cognitive price of doing whatever the task is. So, by nature of our jobs, we have to use a certain amount of working memory because, there's logic to do. There's things to figure
Right.
out. There's also extrinsic cognitive load, which is cognitive load that's unnecessary. It's the things that take up our working memory when we're distracted, or when we have to go like parse through some code that is a little more complex than probably needs be. Um, so cognitive overload is what happens when basically when our brain gets full, or that feeling of our brain being full. It's
Yeah.
when working memory, is just is at capacity, and cognitive load is too much for us to be able to effectively work with the things that we're trying to keep in our head. Um, so so in that sense, I think a mistake that we make, both as devs and as team leads, or as leadership on a team, a big mistake is not realizing the impact of cognitive overload. And I think that takes the form of a couple of things that I can think of specifically. One of those being just um, another example of empathy for your team is knowing that cognitive overload is going to strike. It's going to strike unexpectedly, um,
Yeah.
and knowing that it varies from day to day. So when we're estimating tickets, for example, knowing that a three a 3 point ticket looks different today than it does tomorrow. And
Yeah.
it doesn't mean that we have to panic and like push our estimates and our deadlines back that are a few months out. It just means that today my 3 point ticket looks like a one, and tomorrow it looks like a 16 or an eight. Um, Cognitive overload
That's a really
differs.
good point. Like, because when I think about the point thing, like, usually the biggest problem or the biggest variable is that we're not great at estimating, more on like our technical skills, and especially when something is some API we've never used. But to think about it in terms of cognitive load, like, that's the other thing is like we're very much, a lot of this is, a lot of these practices come from older industries where things are kind of predictable. And that's, these are more like our job is cognitive. It's not just, turning a gear or hitting a hammer, or hitting with a hammer or something like that. So like our brains are very, like you said, they're very variable, very variable, whatever. And so like the time it takes to do stuff can vary considerably if like something is happening in our personal life, or like, we're sick. Those are going to affect points, well, or what the time length it takes to work on something. Besides all that, like technical issues we all run into when we're implementing an API, or there's like some issue with our computer or whatever else. So I love that point. That's really good.
Yeah, and it's um you mentioned like yeah something could be happening in our personal life, and that I talked about earlier, empathy is huge. Just knowing that devs are
Yeah.
people, and it doesn't even have to be something major in someone's life either. Like I was talking about with the conditions that affect working memory, it could just be that like my ADHD is raging today. Like it
Yeah.
has the wheel, and it's acting up, or it could just be that I'm in the office today and somebody is like humming a tune that I kind of recognize. I can't place it, but it consumes my thought and I
Yeah.
can't help
Yes.
it. But it's yeah, anything, or bad sleep or bad mood.
What was the tune?
Oh, I still don't know.
Oh, okay.
Still can't place
But
it.
you spent hours googling it and trying to find out what it is.
Oh,
Yeah.
absolutely. I could have just
Well,
asked the
there's. Did you
person,
try
but
Kazam?
oh, I didn't. I should have.
Yeah.
I should have. I
Oh well.
it. I could have asked the person, but at that point, it was like a pride thing. I had to. I
Well,
had
and
to get it
also
myself.
you don't want to admit to yourself that you've got this earworm
Yep.
that you're. So you're like, no, I'm not going to ask the person. I'm going to focus. Yeah, I get it. I get it. Yeah. Um. Yeah. So the other thing I was going to ask and talk about was just like businesses and managers are especially driven by features in the app. So that can be if you drive too, like, obviously you got to drive so much putting new features because you got to make money in order to run the business. But like there needs to be a little bit of slack in the sense of having time to do like nobody's perfect, but to like make the code more maintainable.
Yep.
Let's take a week or two, like fixing these issues where we have these 200 line functions or 300 line SwiftUI views, and like take the time to do that. I think is really important, and also, I mean, the ideal is obviously doing it as you do the features, but that's not always the case. We're
Sure.
imperfect, so maybe like give a little bit of slack during each feature, and also give some slack every so often to do these practices and fix some code that's not highly maintained.
Yeah, definitely. Like you said, having that time to just like a general, go back and look for overly complex code is super helpful for a maintainable code base. And beyond that, yeah, just having a little room in your estimation for any given like ticket or feature, to go back and address the points where you found there to be extra complexity. So, if I'm working over on feature A and it requires that I look at feature B to get some contextual logic or contextual information. If I notice parts in B that are problematic for me, and I find myself, having to dig into the documentation or having to decode some logic that's in there, making a note of that and going back and correcting it. Being, future dev that we talked about earlier, like that's, me now. And
Mm-hmm.
it's easier for me to identify those places where we're kind of tipped into cognitive overload because of having to do some extraneous work. So leaving some time in our feature work to make those corrections whenever they come up
Yeah.
is essential. It is what it's what allows us to have a continually evolving and improving code base that is going to be sustainable long term.
So one of the we talked a bit about keeping your functions small, and part of that is this idea of keeping your logic simple. And that's where we get into that term cyclomatic complexity. First of all, I'll let you explain what cyclomatic complexity means.
Sure. So cyclomatic complexity, for a long time, longer than I care to admit, was a little obscured for me. because it's a big word. And
Yeah, it is.
when SwiftLint would throw that error, I'd be like, oh, that means something that I should probably look at one day, and then like ignore it. As it turns out, it's actually a pretty approachable concept. Cyclomatic complexity just measures the paths through a
Yes.
given chunk of code, through a
Yep.
given function. It's, you to calculate it, it's actually a number. You just give a one for, the normal path through code, and then you basically just add one for every decision that your code has to make. So if there's an if, um,
Yep.
add one for cyclomatic complexity. And so the higher that number gets, like the more paths there are, decisions that have to be made, then the more complex you can guess that your code is. It's a really good metric for identifying where there may be points to come back to and simplify. It's not foolproof. There are some cases where you might have a high cyclomatic complexity and it's still perfectly readable. An example is like enums. I don't think enums are always the best solution, but sometimes they are, and sometimes they're really
Mhm.
readable, and they'll have a high cyclomatic complexity because each of those cases is going to represent, more complexity. And especially if you have nested if else kind of statements in there,
Right.
um,
If
it's
you have a flat if else, it shouldn't be too much of an issue. It's
Mhm.
more like when you start having if and then another if inside and then another if,
Yep.
and it's a weird pyramid of logic. That's probably a good code smell that your cyclomatic complexity is overwrought. And having it more flat, I guess, would help. I think enums probably are too much of an issue if you're doing a switch case statement. I think you're
Mhm.
okay, but like to me, it's always been when I've had these like jagged pyramids of if and if else's that usually is a good indication you should break it down into like smaller functions of logic.
Sure. And the reason that I bring up enums as an example is just that a lot of times we use, or a lot of times I've seen used the enum structure to kind of in each of those cases to have further if else.
Yeah,
Um,
yeah, especially when you get like associated values and enums,
yep.
which is a weird Swift quirk. Yeah, I could totally see that for sure.
So it can get out of control and more complex pretty easily. Um, so occasionally that adds a cyclomatic complexity um, that either could or could not be problematic, um, depending on how things are structured.
Yeah.
Um, I don't know if that made any sense. I kind of got off on a tangent. Sorry, but
Well, no, but I think like like a lot of I think Swiftlet is the one that does cyclomatic
mhm,
complexity. That's a really good tool to just like get started, to understand it, and to like actually
yeah,
like implement it. Like rather than trying to count the points because I can't do it. Yeah, use it. Implement something like Swiftland. Run it on your
yep,
code base. See what you get, and that'll tell you right away. Oh yeah, these are way too many if statements.
yep,
And we'll post some links in the show notes on that. But that there's a lot of problems when you have that. It's difficult to maintain. B, it's like hard to test. There's a lot of issues when you have cyclomatic complex code.
yeah. And
So
in terms
yeah,
of working memory, it shows us where we might hit cognitive overload, because if we have all of
yep,
those different paths, we might be trying to store all of those paths in our working memory at the same time.
yep,
And pretty quickly, we'll find that we just can't. Our brain can't hold that much information, even if it is in like logical chunks.
yeah,
And
exactly.
so seeing a cyclomatic complexity of, I would say greater than like five is a good indication that it might be a place where we want to start looking at extracting things into functions, breaking it down.
Yeah, yeah, exactly. Was there anything else you wanted to talk about before we close out? Anything you want to mention?
Um, Not in particular. Just I think the main idea I want to get across is just humane development being, you know, a way to remember, or a good tool for remembering the limitations of people, and
Yeah.
to, you know, use it to inform the decisions that we're making when we program. Be kind to yourself if you don't, you know, grasp what particular code is doing right away. And be kind to future devs by, you know, setting them up for success. I think that all falls into the category of humane development for me, and, you know, is arguably the most important part of it is just empathy for fellow devs.
Yeah. Yeah, I couldn't agree with you more. If you want good morale and you want to keep your devs, definitely follow some of the guidance here today. Thank you so much, Jill, for coming on. I really appreciate it.
Yeah, thank you so much for the conversation.
Where can people find you online?
They can find me on LinkedIn. Just Jill Scott. I believe I will send you a link.
Yeah. Yep. And then we'll post a link. We'll have your Twitter on there as well, and a link to your talk.
Perfect.
Thank you again.
Yeah, thanks so much.
People can find me on Twitter at LeoGD, and my company is BreakDigit. If you're watching this on YouTube, take some time to like and subscribe. And if you're listening to this on whatever podcast player, please post a review. I really appreciate it. Thank you for joining us, and I look forward to talking to you again. Bye, everyone.